All right, so as I don't remember whose team I gave this to, but there is a necessity to subnetting when it comes to not only administration, but also security, right? It is better to segment your network in order, so if somebody hack into one of those nice little networks you have, better for them to be sequestered to that small network than to your whole network. So I think that knowing the background information is actually extremely important. Would you want to add something else, May?
Thank you.
Such as, well, okay, well, so I know we talked about the range, and the guy extensively talks about subnetting and where things were and how they were broken down. And having this basic understanding in subnetting, I think, was very helpful. Do you agree, Mary?
Yes. Yeah. As you mentioned, okay, since you mentioned the range, so I am a facilitator to between a Montgomery College and Baltimore Cyber Range. So when at the end of the 4 weeks, I wouldn't say one of the top 5. I would say one of those students who survived the 4 weeks will be attending in this great opportunity. Yes. And yes, and so you see the topology, right? We see like a small network topology, but it's very useful for you to be able to see like, hey, if I see if you be able to read the topology and you understand about subnetting and how IP address, each of these IP address are organized, and then that is a necessary skill that you should have. Yes. Yep. Or to be said, please go ahead, go into the IPv4. Yes.
Everybody's clear on what a topology is, right?
We have questions about what a topology is?
I'm just making sure everybody's clear on what that is. I'm not sure that we actually went over that.
We did.
Completely. Oh, was that me on Monday?
I'm a little bit
I guess
hazy.
I did.
It was yesterday.
Actually, I'm a little bit hazy. How would you verbalize it? I feel like
honestly, the quickest way I would verbalize it is a map of your network. Yeah.
Okay.
It's just there's a logical topology, and then there's a physical one, and then so the logical one is basically how it is flowing logically through your network. Like so, it hits here first, then it hits there first, then it hits here, and then a physical is going to be more of like, okay, this is what this is positioned at.
How it was wired, yes, between each other. That's a physical one.
But it's a map.
Yes, it's a map. So if you can't read the map, you cannot hack it or cannot protect it. Or
did we cover all the different types of topology? I think we covered a few of them, but maybe not all of them. I'm not sure if I remember that where that presentation is.
Okay, it's like rings, mesh, partial mesh, bus topology, star topology. Yes.
When you get to the security test, they're not there's so much going to be on whether it's a ring, a star, or a bus, but it will be laying out your topology in the most secure manner.
Okay. But you should be able to look at it and say, oh, this is star topology, physical star topology, or logical bus or something. But I mean, later on, we will give more example of the, we will try to include more topology into activities in the next coming weeks. So
okay,
don't worry about it now. Okay.
Okay. So can somebody tell me? So today we're going to be pretty much in layer 3, right? And which one is it? What is layer 3 again? Of the OSI model, sorry. I should have said that.
So layer 3 is network, right?
Yeah.
Okay, so whenever we're talking about layer 3, we're talking about IP addresses. But when we're talking about layer 2, what we're talking about?
MAC address.
Oh, thank you. Yes, MAC addresses. Thank you so much.
I didn't get the question.
That's okay. Yeah. I repeat myself. That's all right. See, May and I worked so long that she knows exactly what I'm asking. So we are going to be talking about the Internet Protocol, and we've heard already Justin talk about it. The reason why they call it best effort delivery is because it's unreliable, connectionless. And if you think about it, we can talk about the, I guess, USPS system, where if I send, I guess, 2 letters, you know, snail mail to May, unless I do like all that extra stuff in case I'm extra, you know, extra, there's no, I'm not sure that, first of all, they'll come in sequence. I'm not even sure if they will arrive. And also, it's not like I'm calling May and I'm like, hey, by the way, I'm sending you a letter, right? So there are 2 versions, IPv4 and IPv6, and as you heard, the reason why we are very, very slowly transitioning to IPv6 is because we've run out of the IPv4 addresses, okay? So today we're not going to be talking about IPv6 at all. We are just going to stick to IPv4 and keep it simple, all right? So before I go on to this is why I wanted you guys to tell me a little bit more about segmentation. Hold on a second. All right, so if we look at, sorry, not segmentation, encapsulation, we are going to be talking about layer 3 packet header, right? So the first 3 will give you a PDU called just data, right? Then it gets, I guess we're adding layer 4 header, right? And this is now called a segment. And now the segment is getting an extra, I guess, what is the word I'm looking for? It's encapsulation. So now we're going to be talking about what's inside of this packet header, okay? All right, so I'm going to say, kind of understand the fields. You don't have to memorize any of this. I just know that, actually a few of you guys have asked me how to get better at Linux and whatnot. So side note, there are some CTF challenges. Has anyone ever heard of those?
No.
Or participated in them, I guess, would be the other question.
No.
No? Okay, so there are these, so sometimes it's like Jeopardy, sometimes it's more of a competition kind of deal, but there's one that runs in the spring, one in the fall, and I know that there's another company that does it too, but they do more on the forensic side. But for example, they'll tell you, oh, this hacker did X, Y, and Z, can you tell me who it was, where it came from? And pretty much you're going to use tools, including Wireshark, which is a tool that you guys are going to learn during this boot camp. And the reason why I'm telling you this is because during one of the Wireshark exercises, they needed me to be able to pull information from maybe one of these fields. So I would say understand the fields, and then later, whenever you guys learn how to convert binary to decimal and vice versa, it would help you. But those CTF challenges are actually very helpful in, I guess, learning things and actually practicing. Not just Linux, but also all of the tools. And some of these tools you guys are going to learn about within the bootcamp. Okay, all right, so here is just this packet header, right? And obviously the data is the rest of that segment, right? So version is going to be the 4 or 6, right? Now an IPv6 packet header will look quite different, actually bigger, because the addresses are a lot bigger, right? So header length is how big this packet header is. DiffServ has to do with quality of service and which of these packets get priority. And we talked about, like for example, if you have delay, like if you have if you're downloading something, right? It's okay if you have a little bit of lag, but if you are streaming, that's a little different. So this is where we're talking about. I'm sorry, I can't. Okay, yeah, that's fine. I'm sorry, I can't read your, because I'm recording, I can't read your, whatever you put in the chat, I'm sorry. So, what was I saying? Oh yeah, so they get preferential treatment. They go in first, okay? Total length is gonna be the packet header plus the data. The next line, identification flags and fragment offset. So if a packet is fragmented, right? All of them will have the same identification number, right? They are grouped together with that identification number. The next thing are flags. And what happens, and you'll see that in Wireshark, if you ever manage to pull it apart, you'll see, so there's 3 bits, and each of these bits will tell you, A, there's more packets coming in, and it's the last packet. Okay? And the fragment onset helps the receiving host sorry. So if your packets are fragmented, we need to put them back together, right? This fragment offset is going to tell you which packet comes in first and which comes in last. So it helps it put it back together. Your time to live field, I don't know where my mouse is. Okay, your time to live field. So it is actually how long your packet gets to live on the network, right? So the last thing you want is for a packet to keep on bouncing around on the network, because eventually it would get bogged up and then your network is going to fail. So what happens is it starts at a certain number, and each time it passes a router, it goes down by 1 until it hits 0. And when it hits 0, the router that it passes at that point will drop the packet. Okay? Protocol is whatever protocol is being placed within this with this packet. And the last thing here is checksum. So this is really for errors within the packet header. It has nothing to do with errors within the data, right? So as it's getting built, it gets a number, right? And whenever it hits the router will do its own calculation and check that the checksum matches. And if it doesn't, it means there's an error somewhere, and it will drop the packet as well. So at this level, you will have a source address. So the source IP address where it's coming from, and the destination IP address. All right, you know what the data is right now at this point, right? And options, so I keep on reading, you don't always see them. So I'm not really sure, and I guess we don't need to talk about it because it will definitely not be on your security plus incident. Okay. All right, so today, I told that to some people this morning, we're going to be focusing on a lot of math. So technically, you do not need, you just need to be able to listen to me. So make sure you get some pen and paper, because we're going to be practicing conversions. And instead of me talking the whole time, since there's about, 20 of you, I can't really check when someone doesn't understand. So what I'm going to do, I'm going to show you maybe 2 examples, and then you guys are going to go within your groups and do the group exercises I have set up for you. Okay? Echo. Everybody understands?
Yes.
Thank you, May. Wow, it's like the 2 of us.
Actually, what I was gonna say, I can hear you, but it's like, I don't know, you're feeling like your voice gets really deep, and then it kind of goes a little bit too high, and then it goes out. Okay, so I feel like I might be kind of missing some word, like I'm like a second behind to trying to put it all together.
Okay, let me try and change this. Hold on a second.
Okay. I didn't want to interrupt you before, but I really feel like I was almost squinting with my ears to like make sure I caught everything.
All right, is this better?
Yeah.
Okay, all right, thank you so much. So I can't, as I'm recording, I can't look at the chat. So if you have something to tell me, either say something to May or just say it out loud. That way I can actually hear you guys, or actually know what's going on, okay? All right, let me go back to sharing. All right, let's go on with the conversion. All right, so whenever you're looking at an IP address, a portion of it is actually the network number or the network ID, and that's what's common with all the hosts on the same network. And you have the host number or host ID, which is particular for that host. If I use an analogy, that would be, my name is Una Carbani. So the people in my family are named Carbani, so that's my network. And I have a very unique name, which is Una, right? There's only one Una in the Carbani network, okay? So an IP address has a 32-bit binary value, right? And usually, to be more visual, they cut it, you can see it's by 8 bits. And 8-bit is called an octet. Okay, so that is visible for us because this is not easy to read. We also see it as a dotted decimal notation. Okay, so I asked earlier if anybody was knew how to do conversion or had anything to do with IP addresses. I didn't get not everybody said yes. How are we feeling about conversions and IP addresses?
So far, so good.
Nice. Okay. All right. I have MacGyvered. I don't know. We shall see how this works. Usually I use my iPad, but oh no, hold on a second. Making the co-host share.
I think yes.
All right, let me see.
Which Una? The Una in the matrix or the Una with the whiteboard?
Hold on a second. Share. We're about to find out. Oh my God. Hold on, guys. Let me make sure this works.
You're trying new technology every day.
Trying. You guys should see. Oh.
Oh,
Wait.
nice.
Wait, hold on. No.
No.
Hold on a second, guys. Ah, no, that sucks. It's funny. I thought it was going to work. I guess it did not, right? That'd be the time where everything falls apart. Hold on a second.
It's okay.
All right.
While you're fixing it, I want to say something. Remember that there is 4 octet, right? And the first octet, second one, third, and fourth. So later on, when we do subnetting, we're gonna ask you about what is the 4th octet. So when we refer to that, you should know what we meant. Like first octet, second octet, which one is the 3rd octet, which one is the 4th octet. So
All right. Bear with me at this really crazy looking setup, okay? All right. All right, cool. All right, it's a little easier because I don't know if you guys tried the whiteboard on Zoom ever. It sucks. All right, so the first thing we're going to talk about bases, right? So back to elementary school, we were doing base 10, things with base 10, right? And what that tells you is how many, all right, we'll see how this works. What it tells you is how many numbers there is, as well as the place value, the value of each place, I guess I want to say. So if I tell you base 10, how many values do we have, do you think?
9.
Nope.
10.
10, yeah,
numbers.
yeah. And what? Sorry, I can see that this is acting weird. Okay, so we're going from 0 to 9. That is 10 numbers, right?
Mhm.
If you think about it, so let's say that we are, you look at your odometer, right? What happens when you go from 0 to 9 goes right back to 0, right? There are only 10 values from 0 to 9. And each of them are going to have a base 10. And what do I mean by that? So if I'm going to give you a number, if we're talking about 3,426, right? I don't know why it keeps on zooming in and all like that. Anyways, so the very first value is going to be 10 to the 0, right? Right?
Mhm.
Hey, we can only see the 3 part.
I cannot hear you. What'd you say?
Oh, never mind. Okay.
You good? Yeah, so it looks like it keeps on zooming in and out. I don't know. It's probably just my iPad trying to do something crazy. Anyways, so the second spot is going to be what? 10 to the first. Then we have 10 to the second power, and then 10 to the third, right?
Yeah.
Right? So if we write exactly what that means, 10 to the first is 1, 10, 100.
1000.
Right?
Mhm.
Right? So if I did 3 times
2 times 100.
I would end up with what? 3,000, right?
Yeah.
Plus 400 plus 200
Yeah.
plus 6, which
No,
equals
20.
304.
Oh,
20, 10,
right.
20.
Thank you. Yes. Let me move this out of the way. Right? Do we agree with this?
Yeah.
Yes.
No.
All right. Someone said no?
26.
Ah, 26.
Yeah.
Woo. I'm just checking that you guys are paying attention, of course. All right.
Now I agree with it.
Yeah.
All right. So now that we got the basics, we took a little trip back to elementary school. Let's move on to base 2. Okay. Ooh. You guys should see my setup. It is frightening. All right.
It's working.
I know, right? But I'm expecting it to fall anytime now because I'm moving way too much. All right. So, and now it's a little weird. Okay. Well, I'll keep on going and then we'll see how this goes. All right. So if I'm talking about base 2, how many numbers do you think we're talking about now?
2.
2 numbers. So now we're talking about 0, 2.
1.
That's right. So only 0 and 1 will work here. Okay. And so that means that we're going to be dealing with the power of 2 place values, right? So how many bits in an octet?
8.
8.
That's correct. So let me get it ready. 4, 5, 6, 7, 8.
Yeah.
Awesome. So we're going to do what like we did with decimals, right?
Yeah.
2 to the 0 and so on and so forth. Nice. Right. So some people value memorization. I don't. I kind of like to know what's going on. That way, when I'm freaking out at an exam, I know exactly where to go back to, right? So if you don't know what 2 to the 4th is, that's okay, right? Because there's an easy way to figure this one out. So 2 to the 0 is what?
1,
All right.
2.
4, 8,
8, 16,
16,
32.
34, 64, 128.
All right. So if you don't remember, just remember it's like you multiply by 2 each time you hop around.
Mm.
Make sense?
Yeah.
All right, cool. All right. Now we are going to learn how to change things. Okay, actually, yeah. So if I were to tell you, and I'm going to probably, I guess, cheat a little bit. I have my calculator, so I don't make any mistakes. All right. So I'm going to start with a number, and we're going to go back and forth on figuring out what it means in decimal and binary, right? So I want to change 192 into binary, okay? So I'm going to start from left to right. So if I have 192, can I remove 128 from 192?
Yes.
Yes.
Okay, I hear a yes.
Mhm.
Boom. So what am I left with? I'm cheating. All right. I'm left with 64. Okay. So as I move down the line, I'm left with 64. Can I remove 64 from 64?
Yes.
Nice. So now I'm actually left with 0. So I know I won't be able to remove anything else, right?
Right. So that means the rest is 0.
Correct. Okay. So remember, you moving from left to right. So now if you're still with this, right? And I like to leave my numbers down here, even for later purposes. You'll see for subnetting, it's important. If I just look here, I know to just add the numbers where there's a 1. If we go back memory lane, it would be like saying 128 times 1 plus 64 times 1 plus 32 times 0. And we already know anything times 0 is 0, so it doesn't matter. So really all you have to do, wherever you see a 1, just add the numbers. Okay? Shall we do another one?
Yeah.
Or are we good? Another one?
Yeah.
All right. Cool. All right, let's do, uh-oh. It has happened. No, what happened?
Your battery died.
No, it's plugged. Didn't I tell you something would happen? Okay, you guys start. We're going to do 220, the number 220. Go ahead. No, what happened?
With the same feeling. Una?
Yep. Yes, what's up?
At least it happens towards the end.
Okay, hold on one second. What is
He
happening?
gave us a pop quiz.
I'm just checking that you guys are paying attention, of course. All right, hold on a second. Start broadcasting. Oh man, I hope this doesn't happen multiple times because that's going to be very upsetting. All right. Okay, we're gonna try 220, okay? I think. Yeah, is that the one I got? Yep. So What did you guys start with?
It was,
220?
yeah,
Minus
128.
128.
Minus 128. Okay. I'm left here with 92.
92. Then minus 64.
Uh-huh.
Then
So
we remain
don't forget
28.
to add, right?
Yeah.
Okay. So I'm left with 28, right?
Then
Can I
yeah.
remove 32 from it?
No,
No.
0.
So you got 0 there.
So minus 16 now.
Uh-huh.
So you got a
Then
Then what's
1.
that?
12. We remain 12. So we'll
Uh-huh.
put 1 in the 8.
Uh-huh.
Then 4. 1 in the 4. And then 0, 0.
Awesome. There you go. Boom. And may I ask you, so how many octets in an IPv4 address?
8.
8.
4.
4 octets.
Woo, yes,
Oh,
4.
4. Oh no, I'm sorry. Yeah, I was thinking.
So-
I was thinking the place.
Right.
So if I give you this,
So Una, one quick question. So how it comes like 4 octets?
yeah, 4 octets, yes.
Divided into 2, right?
No, I'm confused. How?
4, 4.
So here, right here is just 1 octet, right? Right? This is 1 octet, right? There's 8 bits,
Yeah.
right? 1 octet is 8 bits. So this is 1 octet, this is 1 octet, this
Right.
is 1 octet, and this is 1 octet. So
Right.
you'll end up having 32 bits down here, right? I'm only focusing on one number at a time because that's a lot, right?
So now
Okay.
you are giving us the 4 octet equation?
No, I've showed you 2 different things that sound like you guys are uncomfortable. This is what we're gonna do next. May, are you still here? May?
Yes.
Could you please release the first group exercise? It's right under the lessons. It should say
In Canvas?
conversion, some IPv4 conversion groups. Actually,
You
let me
mean
pause this.
in
I'm gonna pause
Canvas?
the recording, guys. Let me share. All right, share this. Alrighty. So we did this already, right? I guess whenever you look at the PowerPoint, this is what you'll see. But you guys already understand what's going on. So we're gonna go to the next thing, which is subnet mask, right? So the way you differentiate the network ID from the host ID is by applying the subnet mask, right? So before we go a little further, the subnet mask, there are ones from left to right. So in the in each octet, it can contiguous, right? So it can't skip. So it's from left to right, right? So if the zeros, they're going to be trailing. They're never going to be in the middle. And I'm going to explain why this is important. So by now you should know exactly what this means, right? The decimal and binary equivalent. So if it says, actually, I'll ask right now. So what is the lowest number you could have in an octet?
One.
The value, this decimal value, what is the lowest number?
0.
Yes, very good. And what is the highest number?
Well, you're in the camera.
255.
255. Somebody say something to me?
128.
No, 255. So if all ones, if you got all ones in an octet, 255. Okay? So if you see 255, you know that all the bits are what we say we say on. When you say 1, the bit is on, right? And when it's a 0, it's off. So if you see 255 anywhere, you know that octet, all the bits are on. Okay? So what's the subnet mask for? So this is a way for us to figure out if 2 hosts are in the same network. Okay? So if I apply the mask to the IP address, it's going to tell me the network ID. Okay? So we're going to go one at a time so I don't skip too far ahead. So if you look at the IP address, 172.30.15.12, right? What's going to happen, there's going to be something called ANDing happening. So we're going to use the subnet mask. We're going to lay it out binary. And we are going to multiply it. I know it says ANDing, but if you think about it as a multiplication, it shouldn't be too confusing. So if you do 1 times 1, you get 1. And anything times 0 becomes 0. And so on and so forth, right? So remember I told you, when you see 255, what do you think about the octet? All the bits are?
All ones.
On, that's correct. But if you see zeros, all the bits are off. okay? And we know that it's never going to be like 0 and then 255 after, because those ones have to be contiguous. They have to be one by one, right? No skipping with zeros in the middle. So the reason why it matters is because that is how IP determines whether two hosts are on the same network or on remote network. So we're going to take the long way here, and you're going to pick the source IP address and the mask, and we're going to do the destination IP address and the mask, and you're going to tell me what the network ID is, okay? So just do the first 2 lines first. Let's figure out what is the network ID for this very first one, okay? I'm going to start writing it down, and then I'll turn on my camera so you guys can see what I did, okay? So I want you guys to start ending the 2.
So Una, one quick question.
Yep.
So the source IP is the, I'm confused about the max.
Yeah, so the mask is what differentiates remember your IP address is your network ID and your host ID, right? So your host, your computer is inside of a network, right? But its full name, kind of like your name and my name is, for example, my name is Una Kurbani, right? So Kurbani is my network, my family, and I'm Una. I'm that one entity within that network. Same thing with your computer, right? So the network has an ID, and within that ID, you have a bunch of little computers, and each of them have their own ID, right? But the IP address is both the network ID and that host ID together. So right now, what I want you to do is I want you to give me the network address, the network ID of this specific computer, okay? So an IP address is its address, right? The computer's address, right? I want you to tell me what is the network ID and what is the host ID.
So host means your computer ID, right?
So that would be who's Una and who's Kurbani?
Correct. So if I told you, so yeah, if we use that, right? What is my network ID? What is my network? It would be Kurbani, right? And then what would be my ID, the host ID? It would be Una, all right? If you don't understand this, it's okay. I'm about to pull up the whiteboard, okay? Just give me 1 second.
Una?
Yep.
So the network ID is always going to be the first 2 octets?
No. No, it's not. It's not going to be the first 2 octet always. It's going to change, but right now I need you to be able to understand by just looking at the subnet mask where the network ID is.
I would say that the purpose of this short bootcamp, we will only focusing on IPv4 class C. Okay, we will not talking about class A, class B of IPv4 yet. And those are network. So IPv4 class A, the network will be the first octet. And the IPv4 class B, the network part will be the first and second octet. So now we only focusing on understand the IPv4 class C. So the first two.
Wait, I haven't got there yet. Don't go that far. Don't go that far.
Okay.
You're going too far. Stop it.
All right.
It's the slide right after. Sorry, I'm trying to write all the 32 of those bits. All right. Okay, let's try to share this. Hopefully everything is fine. Screen. Did it work? I don't think so. Can you guys see my screen? No? No? Oh. All right, let me do this again.
I see your hand.
All right. Okay, good. All right, we're getting somewhere now. We're seeing something? Yay! All right. Okay. So this right here is this in binary, correct? So now what you do is you apply the subnet mask to it. So 255, how many ones is this?
8 ones.
Yep. Another 255, so you know it's a bunch of ones, right?
Yeah.
And then 0 and 0. So I think this is 8 zeros. I think this is, all right, cool. So the thing is, so first we're going to look at the source IP, right? And I'm going to find out what the network ID is. So what you do, you end, right? It's like, so think about it as a multiplication. So there's actually a pattern to this, so I don't have to do the whole thing, but I guess we'll do this and then you tell me what the pattern was, right? So I'm going to keep on doing by ones, right? And then all of a sudden these are zeros, so I know I'm going to have a bunch of zeros here, right? Because I'm multiplying, and anything multiplied by 0 is 0. That's correct. Right? So what is this? Can somebody tell me what is this binary? Quick calculation.
It's 172 point.
Yeah, 172.
It's all ones, so it's the same because it's the same because you're multiplying it by all ones.
And then these are going to be what?
They're all zeros.
0 0.
Cool. Okay, so already one person has figured out the pattern here, right? If you're going to multiply everything by 1, it's going to be the exact same number, right? So if I tell you, hey, this is your subnet mask, all you have to do is look at your IP address, and wherever you see those 255, you know it's going to be the exact same thing. Right? And right now we're sticking to what's called default subnet mask. And I'm going to explain that term in a little bit. I guess you can't really see that word. Okay, default subnet mask. Yep.
So you're saying that wherever you see the mask of 255, then the IP address, the first two numbers are 172 and 30.
This would change. It would be 65 right here. I'm applying a bunch of ones to this number. It's like saying 172 times 1 is 172. 65 times 1 is 65. That's what I'm saying.
So yeah, if the subnet is 255, it's always gonna give you the same number of whichever octet is 255.
Yes, that's exactly what I'm saying.
Una, the 255.255 that can be changed, or that will be always 255.255.0.0.
So right now we're dealing with default subnet mask, and that's what May was trying to jump the gun in. We're about to talk about the other default, right? So right now this is a class B. It's class B, but hold off on that. But that's what May was trying to tell you.
Right. Oh, okay, about class C, because usually we would see 255.255.0.
Exactly. So this is going to change. It is not always going to be this, but right now I told you, here's your subnet mask. Now tell me, so now that you've understood the pattern, or to some extent, what is, because we're applying the same subnet mask to this IP address down here, correct? See that? So what is the network ID for this IP address?
172.30.00.
Yeah.
Is it the same network ID?
No.
No.
Oh, sorry, no. Sorry. Okay, is this the sub network ID?
Yeah.
Yes.
Okay.
The same subnet.
Okay,
yeah.
Una.
Yeah.
You threw me off when you changed that 30 to 65.
And back to 30. Okay, I changed it so that you could understand that this is mirroring 255.255.00 is mirroring this IP address.
172.30.
Right. If this had been 172.65.15.12, then your ID would be 172.65.00. Does that make sense?
Yeah.
I'm gonna do another one in just a minute. Okay, all right, cool. So
I think it would be like the IP, which is the first one. That's una. That's the first one, and then you multiply it by your last name, right?
Yeah, you're going really far into this. Yeah.
I don't know. I'm trying to keep that analogy. So basically, if you multiply your first name and your last name, you get your network ID, right?
If I multiply my full name with, this would be just something that just asked me, are you a Carbani, right? And the answer would be, yeah, this is just Carbani. So this analogy, not very good when it comes to ending. Okay? That is just to make you understand. Yeah. What's up, Pooja?
Somewhere I read that the IP address could be changed. So that means because of the subnet masking multiplication, so the IP changed, right? When it comes to our let's say laptop, but just 172.30.15.12 is the general. Then when it comes to our computer, because of this subnet masking, it changed. Is that correct?
Does it change? No. Your IP address is not good. So okay,
because,
that's like going down the rabbit hole. It's not going to change.
Yeah, that was a good question.
So in the destination, it's changed because the 1512 disappear and it goes 00. So it is changed, right? Or am I going the wrong way?
No, basically the subnet mask tells you what network ID you are in.
Right.
That's the whole point of the subnet mask.
Josiah and I are sitting at school in Montgomery College, right? And we're in the exact same network, right? This is my IP address. This is Josiah's IP address, right? Now, what IP is going to do is going to look at the source IP address and the destination IP address and make a decision on what it needs to do next, right? So IP is going to say, oh, wait, let me check with the subnet mask applying to each, right? And it's going to say, you know what? It's in the exact, good Lord. Okay, it's going to say, okay, it's in the exact same network. So I have to do a bit less work, right? So what happens next is it's going to use a protocol.
I cannot see your screen.
I know. It shut off on me again. It's playing tricks on me, you guys. I don't know.
All right, you back up.
All right. Whew. Okay.
There we go.
So what the decision is going to make is, let me find out within this network who has this IP address. We're stuck in the same network right now. However, if this was this right here, I'm going to change this, right? I said 65. If this is 65, right? If Josiah's IP address is 65 right here, what is this network address? What is this new?
65.
172.65.
Yes, yeah, the same.
That's zero.
So now it looks at it and it's like, wait, these two are not in the same network. So what I need to do, I need to find my default gateway, so the router, so it can get out of the network and go find this address somewhere else. This is another place. This is somewhere else. This is not the same network anymore. Does that make sense? So IP does this to figure out if the two hosts are in the same network or not in the same network.
Right, which can be in the same building.
Yes.
Or like
a
Soho. Or
like a what?
Or how May was talking about Soho the other day. Again, maybe that's
small office, home office.
Well, that would be in the same. That would be probably in the same network, right? Because that's something very small.
Right. I mean, yeah. Even though it's going out, they still have to match.
Right. Yeah. Okay. Oh, sorry. I didn't understand that. Yes. Okay. Yeah.
So exactly. On this example for this subnet mask, 15.12 is the host ID, correct?
15. Yes. Yeah. 0.0.15.12. That's
your computer.
Yeah. That's the host ID. Correct. So right here just dictated the network ID, and right here told you which one would be the host. So host. Network.
So Una here, 15.12 means Una, and 16.101 is Josiah, right?
Yeah.
And the 172.30 is the network?
That zero is the network ID at this moment. Okay?
Okay, yeah,
all right.
You.
So it is 11:20. We're spending more time than I was expecting. I love it because you guys are really engaged. Usually it's complete silence and nothing but crickets. So,
I mean, I don't know. I had another question also, but
tell me.
Well, I understand they're in the same network, but it's not within the same IP scheme. So, but I guess maybe that's what we're gonna touch base after.
Okay. I just want to add something. Is that okay, Una?
Yeah, go ahead.
So guys, when you look onto this whiteboard right now, all you need to pay attention is look at the IP address, right? It's only 4 octet. That's all you need to pay attention. First octet, second, third, and fourth. And then compare it with subnet mask. Yeah, so if the subnet mask is 255.255, that means it takes the 2 octets. And those 2 octets is a network ID. So what happened if it's 255.255.255 is subnet mask? What is gonna change on the 172.30.15.12? Tell me what is a network ID?
So we will add 172.30.15.0.
Yeah.
Exactly. Right? So what if Josiah, now he's happened to have a class A subnet mask, so he's gonna do 255.0.0.0. That would be his
right. But May, so the thing is, it wouldn't, since it's coming out of my source, it wouldn't know that it's class A because it uses the subnet mask to double check between source and
okay.
and destination.
And Una was right. Because right now we're talking about routing within the same network.
Right.
So it will check by doing an AND, right? Well, AND.
Yeah, ending. Yeah.
Ending, the router making a decision now whether I'm gonna send a data within the same network, or I would forward it to another router because this is not the same network from the destination and the source IP. That's all we're focusing right now, right? We want to know, is it the same network or different network when we compare two IP for now, all right? Okay.
Alrighty, guys. So now what we're going to do, I'm going to pause the recording and refresh your page.
Yeah, I think you should compare clear two IP address and then make a decision whether we should ask the router to push this packet forward to a different router because it say, nope, this is not within my network, right?
So the the subnetting would allow you to go like how we did yesterday, the networking example with sales and HR, and the other one. Would I use the subnetting to separate them?
So right now we are not at subnetting yet, right? Right now we're just at networking. I know you guys you know your stuff, but don't jump the gun just yet because I need to make sure that you guys understand the basic, right?
Okay.
Yeah. So right now we're just at networking. We haven't even started yet on subnetting.
Okay. So once we understand this, then we can go into how they logically actually apply.
Exactly.
Yes.
Gotcha.
Okay. So are these two IP addresses in the same network?
Yes.
You said yes. Who else agrees that it's yes?
Yes.
Yes.
That's wrong.
No, because the 12 and the 16 are.
But we just need to check the first two, right?
Oh, the third one.
That's what I thought. That's what I thought myself.
The 12 and the 16, though.
Exactly.
All right.
Yeah, I have one question right here. So
255.255, yes, we on the same network because both of the IP have 192.1.
The same, yes.
Okay, so
the first half or the first two octaves, which is I thought what the question was.
so how many octet is determined by the marks? The subnetting, the 255.255.255. If there is again 255, then we have to see the 4 octet, right?
It's never
but the
4 octets.
I mean,
right. So
I mean the 4, what is it? The 192.18.16.0. We have to compare everything. Before in the example, we just did the 255.255. So we check only 2 things, right?
Right. Right. I think what, and I agree with Pooja, I think what I understood as far as for the question is if the first two, which is 255.255, are the same, that they are within the same network is what I understood.
Yeah, same here. So I got
Now
confused.
let's do the next one. Una just wrote the 255.0.0.0.
Okay, so here, if you look at it, this is the first octet, second octet, third octet. It means that the first 3 octet have to be the exact same because this is going to multiply by 1, right? So earlier we had 2 octets. It was only asking for the 2 first octet to look the same, right? Now it's asking for the first 3 octets to look the same, right? So here, the first 3 and the first 3 are not the same at all, which is why we know that it's not the same network. Because what is the network ID here, guys?
192.18.12.
Yes.
0.
Yeah. So this is already in the network ID. Okay. What about? So maybe I should have done like, I don't know, 8. That would make more sense. Okay. And then what is? Okay, this is an 8 too, guys.
Yeah.
What is the network ID here?
192.18.
That 18, that 16.
0, right? Because 1, 2, 3 will dictate the your network ID. It's okay. We're gonna move on. I want to make sure you guys understand default subnet masking. That's gonna be part of the next couple PowerPoints. Just understand what.
One quick question. So this is not default octet, right? Because last time you said like default will be the only 255, right?
Oh no, this was when, okay, if it's 255, that 255 is class B.
Default.
This one is class C, which is what's gonna make the difference of us determining what network is on. That's the difference.
Right.
Okay, and then to wrap it up, Una, one question. So if there are 255.255.0.0, then you only need to look at 192.18. They need to match up from the source.
Right. That's
and then
class
if
B.
there is and then if there is 255.255.255.0, then we need to make sure that the source IP and the destination IP's first 3 octets are the same.
Correct.
Exactly, Robert. Okay.
Okay.
I'm gonna do one last one. So that's what I like whenever you guys kind of like work together, is that you don't have to just stick to me and May and Josiah. You guys can also help each other out. So this very last one, are they in the same network?
Yes.
Good. Is there,
Yes.
is there a no? Yes.
No.
Yes, they are.
They're
They're on the same network.
They're not on the same network.
They're not in the same
Yes,
network?
they are on the same network.
Okay.
Angie
so-
says they are not on the same network.
Okay. All right. So here, 255
It's
is
the
the
only
first octet.
it's the only one that matches.
So what is this network ID?
150.
That's 000.
Nice.
Yeah.
And what is this network ID?
150.0.0.0.
And this is the class A.
Yeah.
Yeah.
Yeah. I'm not talking about classes yet, guys. So yeah, same network ID. So they're in the same network. Okay.
Oh, okay. So
Okay.
yes,
So we
if
got it. We
we're
got it.
if we're saying that it's class A for just 255.
Yes.
That's 0. That's 0.
Okay. All right. So here's what we're gonna do. I'm gonna give you until 11:45 to look at the group exercise that's next, right? It should not take you long because now you've learned how to eyeball it and work really quickly, okay? Of course, if somebody in your group needs help, then you should definitely go for it, right? Because it's 11:34, that's only 10 minutes. So I would say go for it. And please, at 11:45, come back so that we can move on because there's more to come, okay?
Yeah, sure.
Which one is this? Is this the network address? Which one are we doing?
It should say network address groups.
Okay.
Okay? All right.
Class B?
It would be, yeah, 255.255.0.0.
Yes, class B. So now we're looking at the terminology that they're using, right? 255.0.0.0 is class A. Remember that first octet is the one dedicated for network. And then you go to class B, the two first octets. So 255.255.0.0. And then class C, I don't know whether there's an L here, but 255.255.255.0, right? Here are the subnet mask, and these are default, right? They are going exactly by those octet boundaries. However, we're running out, so now we want to cut these subnet into smaller pieces, right? So instead of having this huge chunk, maybe I have this amount of these amount of hosts for one network and another amount of hosts for the other network. So we're not going into, there's a variable length for subnetting, but we're not going to get into that at all today. Right now, we're talking about having a network and we're cutting into exact same amount of hosts, okay? So here, now what they're doing, they're starting to borrow, for the subnets, they're going to borrow bits from the host ID. So see how it's still saying at 16? They have now started borrowing digits here. Bits, sorry, not digits, right? And they've borrowed 4 bits, right? So now we're talking about network ID, subnet ID, host ID. So now the host ID is a lot smaller, meaning there's probably a lot less host in that subnetwork, right?
Can we see an example of what that last bottom one would look like?
Yes, we are about to go and see that. I'm going to bring you, yes, actually, you know what? Yeah, let's do that right now. Wait, hold on one second. Okay, alrighty. Alright. So as I'm gonna also talk about the next slide while I do this. So another thing, so we're moving on now to something called classless. So we're no longer doing the class full, right? Where it's either class A, B, or C. Now we're moving on to something called classless. So if I told you that, so this, what, okay, Josiah. Okay, what class is this right here? You can look back at the PowerPoint I had. What classification is this right here? 192.
Class B.
Nope.
Class B.
Class B. It shouldn't be class B, no.
I think it's class D or E because it has everything there, right? It's using 4 octets.
No. All right, go back to the PowerPoint I showed you with the 3.
Class C?
Yes, it's class C. So what matters, the way you're gonna know if it's A, B, or C is going to be just the first octet, okay? All right, we're gonna go back to, is anybody looking at the PowerPoint right now?
I am, it's slide 14.
Slide 14. So if you look at slide 14, what is the first octet range?
192 to 223.
So that's the class octet for class C, right? What is it for class B?
Class B is 128 to 191.
And what is it for class A?
1 to 126.
Okay. So when it comes to classes, so I'm glad that we got to this. So when it comes to classification, so that class full, they're only looking at that first octet to say whether it's A, B, or C, right? I'm not talking about the network ID here. I'm just talking about the class, right? You will know if it's a class A, B, or C with that first octet, depending on where it falls in, okay? So right now I told you that in this class, we're gonna stick to class C only, okay? I'm not gonna go here because it gets a little too deep, okay? So right now, class C, this is a class C IP address, okay? So can somebody tell me what is the default? What is the default subnet mask for this class?
255.0.0.0.
No.
254.
255.255.255.0.
Yes. That is the default subnet mask for
Oh,
class
because it's
C.
class C.
Yes, exactly.
Sorry, I was looking at the numbers. I was matching back up again. I
That's
see
okay.
that now.
Yeah. So sorry, I'm gonna be a little gross. I'm gonna use my fingers. Okay, so if I told you 172.10.10.10, I mean I can change this. These obviously no longer matter. But what class is this?
Class B.
Yep, right here. And what is the subnet, the default subnet mask for class B?
255.255.0.0.0.
Nice. You guys are getting the hang of this. All right. What if I told you this is going to be 10? What class is this?
Class
A.
Hey, okay.
And what is the default subnet mask?
255.0.0.0.
Awesome. Love it. Good job, guys. All right. So now we're going to move on to custom subnet mask. Okay. And this is where we go.
No, I have a quick question right here.
Yep.
It's a 10 there, so how it became a class A?
So for 10, these are the first octet, right?
Oh,
the
1
range
to
of
10.
the first. I'm sorry? Yeah.
Oh, yeah, I
So
got it.
1 to 126. So it's a class A. But like I told you here, I will stick to class C. So we're going to, of course, you need to, I don't know if you need to know this. I don't remember needing this for the Security Plus exam, actually.
No,
127 was loopback, correct?
127 was loopback address, yes.
It's definitely needed for the networking.
For networking, yeah. I'm saying for when it comes to classification, I don't remember being tested on what class something was.
It comes up in all the books, though. I don't know if you.
Oh.
So you might get a throwaway question. I didn't have a question like that, but I know it's in all the books.
Oh, okay. All right. Thank you. Thank you so much, Josiah. Okay. So what did you tell me the default subnet mask was for this class?
Default 255.255.0.0.
No, 255 again, then 0.
255 3 times.
Yeah.
That's class C.
Right. The first 3 are taken, right? So now we have a brand new way of doing notations, right? We don't put this whole thing. We don't put a bunch of ones. We do a quick notation, number, okay? Very quick notations. So how many ones are here?
8.
8. That's true. There's 8 ones here. How many ones are here?
8.
8.
8.
Okay. So this is how many ones?
24.
So here's our new notation. So if I tell you you know what your subnet mask is, you know what your IP address is. Okay?
Okay.
All right. Now, so I'm going to stop writing all this, right? And I'm going to start focusing on this very last thing, because where are the bits getting borrowed from? Why does it look like that now? Sorry.
From the network.
From the host ID.
from the host ID. That's correct. So I'm going to start worrying about this thing right here. So if I'm telling you, so here's how many bits here in this area?
8.
8. Okay. If I tell you we are going to borrow 2 bits. Oh my God.
Yeah, we cannot see your screen.
That's all right. Each boot camp brings me new problems. All right. Ah, perfect. Is the light too much in the way? Okay. If I tell you I'm going to borrow 2 bits from the host ID, right? So how many, I've just borrowed 2 bits, right? So how many bits are left here?
6.
Yes. Why 6?
0, 6.
2,
Because 8
2
minus 2.
8 minus 2, right?
Exactly. That's correct. You're right. You're right. So I'm borrowing 2 more bits to create my subnet. Okay? So since this has changed, so this used to be 24, right? 8 plus 8 plus 8. What is 8 plus 8 plus 8 plus 2?
26.
Do we see what I just did?
18.
Oh, you changed the last one.
Exactly. So I changed that new notation, right? So here was my subnet, my default subnet mask. What is it going to look like now that I've added those two extra bits?
2 by 5, 2 by 5 dot.
Anyone?
I think 0.
What is it?
No, not 0. We have to convert the last bit into decimal.
Oh,
That's
it
right.
would be 128 plus 64.
What does that equal?
164. 192.
Yes.
Nice.
Here is my custom subnet mask. Okay? All right, we're going to do another one. All right. I'm going to, and hopefully you guys have pen and paper with you. I want to borrow 4 bits. I'm going to borrow 4 bits from the host ID.
I cannot hear anything.
And I think that was a question.
Oh, so
yeah.
what do you want to know?
So she wants us to write the notation for what the IP address would be with the slash representing the subnet if we borrow 4 bits.
So it'd be
right?
255.255.255.240.
0.240. All right, so let's break it down. So I make Pooja, can you hear me or you cannot hear me?
Sorry, it's me. Sorry.
Okay, all right. So I'm going to so I got one answer, so let's see if he's telling us the truth, right? So if I'm borrowing, how many bits did I say? 4, right?
4.
1, 2, 3, 4. So 4 bits are on. That means that how many are going to be off?
4.
4 off.
And we know this why?
Yeah.
No, how do you know it's 4 on and 4 off?
Because there's 8 bits in an octave.
Thank you. Awesome. So there shouldn't be a dot. Anyways, so now what is, so if my address was I don't know, 210.100.56.10, right? So it used to have a /24. What does it have now?
It will have 28.
Nice. Okay. So now I have 255, 255, 255. And how did you get this?
240.
How did you get 240?
240.
I add 128 plus 64 plus 32 plus 16.
240.
Yeah.
Awesome. How are we doing? How's everybody doing? Overwhelmed? We're okay.
I think I'm overwhelmed.
You overwhelmed? Okay, all right.
I was gonna say, I'm like, I feel like there's one little part I'm missing, but like if I do it slowly, I know I'll get it. Because how quickly Pooja and I'm sorry, I forget who else was answering how they jumped to the conclusion. I must be missing something. It's gotta be that easy.
No, you know, there was where I was getting confused. What confused, I think confused everybody, is when you try to start thinking about the class when you're thinking about the subnet mask. That's totally different. They're different.
Right. The reason why we're talking about the class is because that's how I know how many bits are getting borrowed.
Right.
Right? Because if we were in a whole different class, if we were on like, I don't know, what is it, like 172? I think is the one I used or something. 128, I don't know. Whatever, I'm making it up. What do you think is the annotation here? What is the subnet mask for this one? Do you guys remember? What class is this?
B.
B. Right.
It's
It's
B,
B.
right?
So
yeah.
So what is it?
So B.
255.255.00.
Right. So it's 255.255.0.0, right? So I know this is this annotation. So if all of a sudden I see something coming up with this, I know how many bits were borrowed.
Oh.
Right. So that's why you need to know. But right now we're sticking to class C, so you don't have to worry about it, right? But that's how I know how many bits are borrowed to create that subnet.
Mona,
That's
can we
the
do
only
one
reason
more?
why. I'm sorry?
Can we do one more again with the...
Oh, yeah. I was just trying to explain why I'm adding the whole class octet thing. All right.
Oh, thank you. Appreciate it. Because everybody has their own method of doing it. There's many different ways.
Absolutely. Yes, there is.
I want to ask one question. So when we when we classify the class A, class B, and class C, that is making a little confusing to me. So what I understand is class A is whatever the first octet, just like in your screen 210. So 210 lies. 210 is above than 126, so it lies in the class B. Am I correct?
No. So,
no.
My God, this thing is gonna drive me insane today. All right. No. So, you guys are confusing network ID, and you guys are confusing the two together. So we were talking about network ID because I need you to understand what the network address was earlier, right? But this class, where it comes for like class full and whatnot, what's it dying so much faster all of a sudden? Okay. So the thing is, I think it was Tangela.
Network ID was the combination of the host IP and the subnet, right?
The network ID, so the IP address is the network ID and the host ID, right? To know what network your host is in, you apply the subnet mask. And that's why we need to worry about these all of a sudden, right? That's to figure out the network address to see if two hosts are within the same network, right? Now, this is going to tell you whether this IP address is in a class A, class B, or class C. And you only need to worry about that very first octet to figure that one out, right? I think we said 1 to 126, and then this is 128 to, what is it? What's the last one? 190. 191. Okay. All right. So since this is 210, I think Pooja is the one that asked me that question, was it? I don't remember. Pooja?
Yeah.
Okay. Yes. Since this is 210, the very first octet will tell you what classification it's in. Is 210, meaning it's between 192 and 223, correct?
Yeah.
So that's class C. If I told you 10.10.10.10, what classification would it be in?
Class A.
Class A. Okay? So this thing just tells you what class it is. Now, if you want to know the network ID or the network address, you have to start applying the subnet mask.
Where did you get the class A lies in 1 to 126 and class B lies in the 128 to 191?
Where did I get that?
Yeah.
That's the rules. Yeah,
right.
that's what.
Actually, Pooja, I sent it on the chat for you. If you're in the lesson for today, for the PowerPoint, it's slide 14.
Okay, thank you. I will see. Thank you so much.
Yeah, and so then what she just explained would be on the farthest right, where where you use the first octet address to identify the class.
Okay, I saw it. Thank you so much.
Okay, so we were talking about default where things were per the octet, right? Doesn't move past the octet. But now we're starting to do subnet ID. So we're starting to borrow some from the host ID. So now it's no longer clean, right? It's no longer 24. It's going to be more than 24, right? So if I told you I want to borrow,
I understand now.
5 bits, right? If I want to borrow 5 bits, 1, 2, 3, 4, 5. I know that how many are left?
3.
23.
Right. So now this has now changed to slash what?
Plus 5 will 29.
29.
Exactly. That's what it has changed to. This is my new subnet mask, customed. Right now, if you know how to count these, which you've done this morning, you'll know that it's 255, 255, 255 plus. Sorry, dot. What is it? 248.
Yeah.
Okay, 248. Okay. So why am I telling you all this? So this is the last leap that we're going to do, okay? And then after that, maybe we do 2 more leaps, right? So notice that we don't have any quizzes or anymore because I'm completely aware that this is not on your exam, and if it's way over your head, it's okay, right?
Oh,
okay, so what's that?
No, I just figured it out. Sorry, I just got it. I didn't know I was in a mute. Sorry.
That's okay. That's okay. So, sorry. So there are equations, and you can just count. Actually, you know what we're gonna do first? So you guys understand this already, right? I'm gonna erase this. We're gonna do, and I like to leave it on the side when I do subnetting, the bases of 2, right?
Una.
Yep.
One question while you're writing. So class A is 1 through 126. And class B is 128 through 191. There will never be 127?
127 is dedicated for something called the loopback address, and you guys are going to learn that whenever
Oh,
you're
okay.
thinking.
That's what
right,
what Noah was talking about.
Yeah, yeah.
Okay.
Okay. So, bad writing, I know. This is 2 to the 6, 64, right? Okay, all right. Well, all right. That's fine. So there's an equation that to figure out how many subnets, right, have been created and how many hosts are per subnets, right? I'm going to start with that, and then we'll see where we go with it, okay? So you're going to look at your borrowed bits. That last, after the default subnet mask, now we're getting into customs, right? How many bits have been borrowed? How many bits are on, sorry?
5 on.
5 on. So this is now 2. So what is 2 to the 5th?
2 to the 5th is 32.
248. Oh.
Am I doing this right?
Yeah. 32,
Yeah.
yes.
Cool. And then how many are off?
So 3 off.
Probably should be writing this in different color. And what is that?
It's 8.
Okay. So the last thing I'm going to tell you is when you're done with this, this is not your last. So in every network, whether it's a subnetwork or an actual network, the very first address is dedicated for the network address. Okay. And the very last address is dedicated for the broadcast address. So really what's going on, it's actually 6. It's not 8, right? So whenever it comes to usable IP addresses, it's actually 6, right? So it's 2. That's for the math people in the room. Okay, 6.
We lost you, Una.
Yeah, I was gonna say.
Oh no!
I think that's the
Oh my
visual.
god! All right. I thought I lost you with what I was doing, and I was like, ah, completely understandable. All right. Figure out a better way of broadcasting this next time.
It works fine. We're getting the point.
Oh, good. Thank you.
Thank you.
Fantastic. I like to hear that. All right, I'm going to change this, okay? Let's get 26 up in here. And you tell me how many subnets and IP addresses or hosts, right, are per subnets.
Una, I have one question.
Yep.
Okay, usually when you are writing a binary number and you are coming left to right, usually.
Yeah.
But the way you added that to the 5th came from, if you were looking at your scale, we would usually go from the top to the bottom, but you just went from the bottom to the top when you did 2 to the 5th power.
What do you mean by that?
Okay, when you said 2 to the 5th power because you borrowed 5 bits in the last example, you went from 1 up to
I see what you mean. You mean I didn't use this place value? You're talking about place values?
No, usually if we look at a binary number, or when we are putting a binary number together, we put it together from the left, which is 128 being the first column, so to speak, and 64, 32. But when you wrote it like that, but when you said to the 2 to the 5th power of 2 on for the subnets,
I see what you mean.
Right.
Right. So this is a trick. I think somebody else said it before. There's multiple ways of doing this. Who said that earlier?
I think
I did.
So there are multiple ways of doing this. The number that you see on is going to be one of the numbers that you see, the powers here, right? That's the only thing that you worry about. So if I tell you there are 6 bits that are on, is going to be this number here, right? I know you guys can't really see my crappy handwriting, but 2 to the 6, so it's going to be 64.
Oh, okay. All right. No,
Right.
I got it now.
I know it's a little confusing. Let's do, I think, 1 or 2 more, and then we're going to call it for subnetting today, okay?
Okay.
If I give you this right here, right, how many subnets can I get? So how many on? We got 2 on, right? How many off?
6.
Nice. So that means that we have 2 on, so 2 to the 2nd, right? And how many do we have off left?
6.
Nice. So how many subnets?
4.
How many IP addresses?
64.
How many usable IP addresses?
62.
62.
Nice. Awesome. All right. Let's do the very last one.
Hold on, Una.
Yep.
Hold up before you do that. Let me screenshot this real quick. Okay, I got it.
All right. Let's do 25. Alrighty. Alrighty. What do you guys have for 25?
So you got 1 that's on.
How many off?
2.
7.
I mean, no, sorry. 7.
Cool. 7. So how many subnets?
2.
How many IP addresses?
128.
8.
And how many usable IP addresses?
226. Sorry, 126.
Nice. Okay. The silence after I do the first round of subnetting. I'm kidding. How's everybody doing?
Good.
Doing okay.
Doing okay. All right.
Um,
I'm not going to go further. This is usually where I stop with everybody. Usually I go backwards. So if I were to tell you, I'll go backwards once. So obviously this doesn't matter because I'm staying within class C. So I'm not going to change this. We already know it's class C. This would matter if I started asking you to give me the ranges, but we're not going to do that today. I'm going to go backwards once. All right. If I tell you that I want, this is what I want, right? I want 6 subnets. Actually, no, let's keep it clean. I want 16 subnets. What do you think will be my new subnet mask? Can you work this backward?
4.
Yes, 4. So how many bits on?
4 bits on.
Nice. So how many bits do you think will be off then?
4 off.
So how many IP addresses?
Again, 16.
How many usable?
14.
Yep. Right? Okay. So if I give you a number that was too high or too low, you need to go over. I'll do one last one. I know I told you that was it, but one last one and then I'm sorry, what was the new thing here? 28. Yes, it was 28 because I was 4 more bits, right? Okay. Very last one. I want, so per subnet, I want 45 hosts. So obviously I want them to be usable, right? 45 hosts, right?
Mm-hmm.
If I want 45 hosts, what do you think I need to have here? I can only stick to these, right? Because these are the only possibilities I got. Oh my God.
We lost you, Una.
I know. This is becoming, I'm glad we're almost done because I'm going to lose my mind here. All right. Last thing, I promise. Okay. So if I told you I want 45 hosts, I'm like, hey, I need 45 hosts per subnets. What can you offer me here? Are you going to give me 32? No, because that's too little. I don't.
We need to go to 64, I guess.
Yes, we're going to go to 64. What's how do you get 64?
7.
2 to the power 6.
2 if you borrow 2.
So what's up here?
It's 2.
Oh, I'm sorry. I heard the answer and I didn't even register. Nice. So how many subnets will I be getting?
4.
2.
Right. So how many bits are on?
So 2 on, 1, 1, 6 on.
Nice. What's my new? What's this?
26.
I'm just confused right here, Una. So when you say you need 45 usable, no.
Yeah. What?
You said 45. You need 45 usable IP address, right?
That's correct.
So we went to the 47, adding +2, but we don't have the 47 number in the 2 to the power n. So we went the upper one, 64. But in this case, we are wasting the space. Are we?
We technically are, but right now, I would not be getting how many hosts I want, right? I can't get 32, right? So there is a waste, and that's why Yeah, it goes deeper, right? There's something called variable. I forgot the full name for it, but you can keep it. You can vary, so you can cut this even smaller if you really wanted to. But we're not going to fall down that rabbit hole. So this is really the beginning of subnetting. If you at this point manage to understand how I got to 26, and you're interested in more, there's so much more out there for subnetting. And actually, I love subnetting. This is, to me, it's fun.
It's a VLSM, right? What did you mention?
What'd you say?
VLSM.
Yeah, that's the one I was saying. You can cut it even more, and you can have even, so one network can have 26, 27, it can have a bunch of them. Right now, we're all cutting them in the same pieces. So right now, you'd have 4 subnet, each with 64 hosts, right? But in reality, you could have 2 subnet with 64, and then 2 other subnet with, 30, like, it can change. It can change. That way, you use the one with the less, a smaller amount, so you don't waste IP addresses. But that's like far down the road, and I think this is a good point to stop. It's 1:47. I think we're doing good here.
Thank you so much. Yeah, thank you.
Yeah. And then I think someone asked me how to get 4 subnet. I know how many bits are on. I work backwards, right? If I want to get 64 IP addresses,
was easier for me, but I didn't get back to 26. I followed up until 26.
One more time?
I said I got the 64 and I followed it backwards. That was easier for me, but I missed the 26.
You missed the 26?
Yeah.
Okay, so here it gives you 24, right?
Right.
I added how many bits?
2. Oh.
24 plus 2, 26. Okay. Yeah.
Got it.
All right. So usually I know that the ending is a little confusing for people. And again, that's okay. I'm not even going to put this. This is not going to be part of Friday's challenge. Just make sure that everything this morning worked out for you. Pay attention to the quizzes. If you've had good grades, you'll be fine. If not, this is a great time for asking. Yes.
So the 45 is the usable IP addresses. Is that what
yes. That's correct. Yeah.
Well, actually, no. There's 64 usable, which would allow her to enable 45 possibilities, which was the question.
Yeah, I'm sorry. Yes. So my boss wants me to have 44 hosts within each subnet, right? I cannot give him 45, right? Because all I can do is give him 32 or 64. Yes, that's a big gap.
Right. Okay.
Right?
Okay.
Right.
Now I understand.
Right.
Okay.
Right.
I think that was Pooja's question as far as that you can have further custom subnetting, right?
I'm sorry. What was the question? One more time.
No, as far as Robert's question is that was Pooja's question as far as to further explicit subnetting.
Yeah. It goes further down the line because now I know how many per subnet, so I can tell you the range of each subnet. It goes a lot further. So right now, this is where we're gonna stop. But yeah, so it's like your boss is asking you for a certain amount, you can't give him under, right? You can only give him above. Right.
So now I understand. I mean, so basically when you were, so basically the analogy of your boss wants you to have 45 usable IP addresses. So that's how that if you would have said your boss wanted you to have 64 IP addresses, we would have done it oh no, okay, I got it.
Actually, right.
Right, like if she would, if the number was 65, then that would change.
You have to give 128.
Exactly.
Got it.
Yeah.
If you need to get 64 again, you have to go to 128, right? Because it should be added plus 2.
That's correct. Also, if I told you I want 64 usable IP addresses, it won't be the same, correct? Because now I need 66. This needs to go to 66, right? Because 2 of those will not be used. Remember, we talked about this. The very first address is the network. The last one is the broadcast. So this would not be 6 right here. We would go up 1. I guess this one is a bad example. Maybe if I told you 32, right? This would not be 5 here because I need more, right?
Mm-hmm.
I guess I don't know if I'm making sense. Yeah. So just keep in mind whenever you do this that there are 2 IP addresses that are not usable, is what I'm trying to tell you, in a very crazy way. Okay.
Yeah.
Oh, right on time. Okay. If you can't see me anymore, that's fine. That is fine. So I say, let's, shake it off, and then we'll start some daily Linux in a little bit. Okay. How's everybody with their setup? And I'm talking about Ubuntu and whatnot.
Good.
Good.
Una, I think
Yep.
if you can help me check mine, just to be sure.
I have to check yours?
Yeah.
Okay.
Jerem, did you get yours done? And I also need your paperwork still, sir.
So should I share my screen, Una?
Yeah, you go ahead and share your screen. Yeah.
All right, thank you.
Yeah, excuse me, Josiah.
Yes, ma'am.
I cannot set the GNS3 for yesterday's lab, and I didn't do that. GNS3.
Una, you want to switch with me?
Yes, I do.
Okay. So you help her and how I help him, because I don't know. I haven't touched GNS3 since the beginning.
I can do NS3 in the different room you want.
Okay. That was Angie. So Angie, go with May, and then I will take
No, that wasn't me. I
Oh,
think
that was you,
I think
sorry.
that was Pooja.
Oh, Pooja. Okay. So
GNS3 is me, yeah.
okay, so May and Angie in the breakout room, and then me and
Me and Pooja.
oh, okay.